All right, we are back with lesson 7.7. Excuse me. We are on page 340. We're going to be solving inequalities. This time we're going to be using multiplication and division. So, we're going to follow the same process using the fence. Again, the book doesn't show the fence method, but that's exactly what we're going to be using. Remember, when you see a fraction, this fraction bar means to divide, so the opposite would be to multiply. So you can see that they're multiplying by 5 on both sides, and then solving it, and then graphing it using a closed dot because it has that extra line, extra color, and pointing in the directions that would make that solution true. So I'm just going to jump into 1, 2, and 3 because basically we're doing the same thing that you did in the last lesson, except instead of adding and subtracting, you're going to be using multiplication and division. Otherwise, everything stays exactly the same. All right, so number 1. So P divided by 3 is greater than 2. So we're going to make our fence under our inequality symbol. Circle the number on the variable side. So you see division, so we're going to multiply. So times 3 times 3, this cancels out. I'm left with P by itself. Keep it as a greater than symbol. 2 times 3 is 6. So P can be anything greater than 6. So no extra line on the bottom, so no extra color. That means it's going to be an open dot right on the 6. And then I'm going to think of 3 numbers that would make this statement true. Tell me a number that is greater than 6. That would be 7, 8, or 9. Well, that would be going in this direction because 7 would be there. Here's 8, there's 9, so it's going to be going that way. All right, number 2. 3/5 times Q is less than or equal to 6. Make your fence under the inequality symbol. Circle the number on the variable side. Remember what we do with fractions, though? Starts with an R. Multiply by the reciprocal. So what does that mean? Flip that fraction over. So I'm going to multiply this by 5 over 3, even though this says multiply, but look what happens when we multiply it by the reciprocal. Cancel, 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 cancel. Everything's gone. I get Q all by itself, which is what my goal is. But if I multiply this side by 5/3, I need to come over here and multiply this side by 5/3. Again, I can put that over a 1. Cross cancel. 3 can go into 3 once. 3 can go into 6 2 times. 2 times 5 is 10 over 1, which would just be 10. So this time I see less than or equal to, extra line, extra color. And now I got to figure out what direction. So Q has to be less than 10. So tell me a number that is less than 10. Well, 9, 8, 7, those are all less than 10. I don't see any of those, but those would all be smaller, all in here. And again, I don't care what you count by. Pretty sure your online assignments will be using a variety of ways to count, whether it's by 2s, 5s, 1s, just a bunch of different options. Okay, so number 3, make your fence under the inequality symbol. My S is up here, that's an S. I want to get rid of this divide by 7, because remember that fraction bar means to divide. What's the opposite of divide? Multiply. So times 7, this cancels out. I'm left with S by itself. 1 times 7 is 7. So now I gotta graph that. Less than 7. So I'm going to put an open dot on my 7. And now I got to think. 7 is less than what? 7 is less than. 7 is smaller than an 8, then a 9, then a 10. So my arrow is going to go that way. And that's it for 1, 2, and 3. Let's go on to example 2. On to the next page. And now we see a multiplication problem. Well, how do we know that? Because when a number is directly next to a variable, that means to multiply, remember? We don't see an X. We could see a dot. We could see parentheses. But that's just multiplication. So what's the opposite of multiply? Divide. So here they have just the fraction divide by 4, divide by 4. They got an 8. Open dot on the 8 pointing to any numbers that are going to be greater than 8. Here is a real life situation about a bus ride. So I'm going to give you a minute again. If you want to pause, look through this, read this question, read it a couple times, look at the very ways they use the color coding to kind of help you. But otherwise, I'm just going to go ahead and go over 4, 5, and 6. And then I'll go over 7 as well. So here we go. I already set my paper up. So once again, make your fence under the inequality symbol. Circle the number on the variable side. Here, this means to multiply. What's the opposite of multiply? Divide. So divide by 11. Divide by 11 cancels out. I'm left with K. Bring down your symbol. 33 divided by 11 is 3. And then here's my graph. I already have it set up. So I see a less than or equal to extra line, extra color, and it's going to go right on the 3. Now tell me a number that is less than 3. Well, 2 is less than 3. 1 is less than 3. 0 would be less than 3. So my arrow is going to point towards those numbers. All right, number 5, make your fence. Circle the number on the variable side. Here they have a dot. Remember that dot means to multiply. So we're going to undo that. We're going to use the inverse operation and do the opposite of multiply, which is divide. So cancels out. I'm left with J by itself. If I divide by 5 over there, I must divide by 5 on this side of the fence. 20 divided by 5 is 4. So here is my symbol, no extra line, no extra color, and my dot is going to go right on the 4. So tell me a number that is greater than 4. 5, 6, 7, so I'm going to point it in that direction. And then number 6, make your fence. Circle the number on the variable side. The opposite of multiply is to divide by 2. Cancels out. I'm left with M. Bring down my same exact symbol. 50 divided by 2, or half of 50, is 25. So 25 is going to be my middle number. As you've been noticing, I've always put 5 numbers. I automatically put my answer in the middle, and then add 2 numbers to the right and 2 numbers to the left. So now I have an extra line, extra color, so I need to color in that dot. And now think of some numbers that could substitute for M. Let's read this. 25 is less than, or 25 is smaller than a 30, it's smaller than a 35, it's smaller than a 40. So again, my arrow is going to point towards these numbers. And there you go. Now we have number 7 down here. We need this passenger car's toll is $2.50. So the sign shows the toll for driving on Alligator Alley. Write and solve an inequality to represent the number of times someone can drive on Alligator Alley with $15. So here, it's going to cost me $2.50 every time I go on this toll road. Do I know how many times I'm going on the toll road? No. That's why I'm going to multiply it by X, because I got to pay $2. Sorry, it'll come back. Okay. I got to pay $2.50 every time I go on the toll road. So if I go on it one time, I could substitute a 1 there, or 2 times, or 3 times, or 4 times, or whatever. But I know I only have $15. So I could spend $15, that would be equal to $15, or I could go less than $15. But I can't go more than $15 because otherwise I wouldn't have enough money. So now once I set up my problem, I thought of this problem based on the information. I knew I needed this $2.50. That's where I just simplified it for the 2.5. I know I couldn't go above $15, and I don't know how many times I'm going to drive on this road, so that's why I used an X. I could have used any letter, I just chose X. And now I'm going to solve it just like I was doing all along. Circle the number on the variable side, use the inverse operation, do it to both sides. Ooh, a little bit more complicated, maybe not as mental math, so come off to the side, do the division. I can't divide with a decimal, I got to kick it to the curb. It's hiding right here, so I got to move it one place over, add my 0, and now I can divide by 25. Can 25 go into 15? No. Can it go into 150? Yes. Well, I'm thinking of quarters. How many quarters could I get into $1.50? Well, 25, 50, 75, $1, $1.25, $1.50. That's 150, so that would be 6 times. 6 times 5 is 30, 12, 13, 14, 15. Perfect. So I know X, this cancels out, bring down my symbol, is less than or equal to $6. $6. Nope, not $6. I have $6. I could go on that toll road 6 times, but I couldn't go anymore. And I don't think it asked to graph, so just write and solve. And so that's it for lesson 7.7. You can now go on to Big Ideas, and you got another 10 problems waiting for you. Have a great week, guys.